last time we talked about using HTML forms to gather input from the user so that we could send that information to a server-side script to generate dynamic content. Today we're going to talk about how we can use the Python programming language to actually write a script and do some more interesting interactive kinds of things. So this is the picture that you should have in mind when you think about how communication happens between the server and the client. So first what's going to happen, we're going to design a page that has an HTML form in it. And that form will usually have a submit button. And when the user clicks the submit button, the web browser is going to collect information from the form elements, and it's going to bundle it all up and send it to the server, usually as an HTTP request message. It might be a post request, it might be a GET request, but the server is going to get that information, it's going to send it to a script, it's going to run the script is going to produce some kind of output. That output's going to be sent back to the web browser, and the browser is going to display it as a result page. So we're going to have two web pages, the one that collects the information, the form, and then one that's generated by the script, one that the script makes using that information. And when the user clicks submit, the web browser is going to replace the form with the new page that's been created by the script. So a couple points about this. First of all, the information from the form is going to be sent to the server using an HTTP request message, either a GET request or a POST request. Most of the time it's going to be a POST request. I think we talked about some of the reasons for that before. A POST request doesn't have a maximum size. A GET request is limited to a small amount of information, I think about 255 characters. Also, we can upload files using POST, and that can't really be done with GET, partly because of the length limit. So the server's response will come back as an HTTP response packet, and this opens the question, well, how do I generate that response? How can I write a script that does something useful and interesting with this information from the form? And the answer to that question is that we're going to use something called the Common Gateway Interface, or CGI. The CGI, the Common Gateway Interface, is a standard that was developed to allow scripts written in different programming languages to interact with the web. So at first, a lot of these scripts were written in Perl. Perl, the practical extraction and report language, was one of the earliest languages used to generate dynamic content on the web. And Perl is great at that because it has a lot of string handling functions that allow us to apply regular expressions and do other kinds of transformation on text. So for really simple web processing, Perl was great. Perl, however, is kind of hard to learn, and it's a pretty complex language. And not a lot of people felt comfortable programming in Perl, and new languages have started to replace it. Well, more than started to replace it. Perl is no longer the most popular CGI language. Instead, languages like Python and Ruby and Go have become more popular. Python's one of the most popular, and we're going to talk about how to use Python. There's some really exciting languages, though. Go is a language developed by Google in just the last 5 or 6 years, I think. And it has a lot of cool language features that I would love to talk about in some other class, but it's not really appropriate for this lecture. But it's becoming very popular for doing web backend programming. There's a language that we've already talked about, JavaScript, that we've talked about using in the browser to actually change the DOM and manipulate the elements on the web page. You can actually write server-side scripts using JavaScript. There's a server called Node.js that allows you to interpret JavaScript as a server-side language. At any rate, we're going to talk about Python. And Python is going to interact with the web through CGI. And CGI has to be language independent. And it basically defines a way that we can send information from the web browser to the script and then retrieve the information from the script. And the way that that's done is that if a POST request is sent to the server, the web server will encode the information that it receives from the browser and send it on the standard input stream. So it'll run the script and send the script the information using the standard input stream. In C++, that's the cin object. In Java, it's usually system.in. If in other languages, it's the input function or something along those lines. If the information is sent using a GET request, usually we don't use standard input stream to communicate the data. Instead, the web server will put it into environment variables in the operating system, and the script can retrieve them from there by making operating system calls. The output from the script is sent to standard output. The web server collects that input, it captures it, packages it up as an HTTP response message, and sends it back to the browser. So our output always comes from standard output. So the standard print statement in most languages will print to the standard output stream. That will be sent as a web page, or as an HTTP response message, really, to the web browser. So a little bit about Python. It was developed by a guy named Guido van Rossum. I encourage you to read about him. He's an interesting character. Python is an interpreted language. That means that it's not compiled. Instead, when we create a source code file, each command that we type into that file will be executed by a program called an interpreter. So it'll load the file, and it'll execute each instruction in sequence. And maybe it reads in some data and transforms it and produces some output. But this is very different from what we do with a high-level programming language like Java or C++. Because in Java and C++, we actually have to take the source code and transform it into a new programming language, assembly code, that can be understood by the computer's processor and executed directly on the hardware. So compiled programs tend to be faster because they're running directly on the processor. Interpreted programs tend to be considerably slower because they have this intermediate step, this intermediate program that's translating them on the fly. However, there are a lot of advantages to an interpreted program. One of the advantages is that we don't have to do this extra step after we create the source code. We don't have to compile it. We'll see that there's some other advantages too. It's easier to make a cross-platform language that's interpreted than one that's compiled, because you don't have to worry about what processor it's running on. You just have to write your program once and trust that the interpreter will handle that for you. In my opinion, Python is very easy to learn, and it's pretty easy to use. They've tried to avoid having lots of complicated syntax rules. So for example, in Python, you don't have to put a semicolon at the end of every line. And we're not going to have any curly braces in Python around our if statements and our loops. Instead, we're just going to use white space. We're going to tab over so that related code lines up graphically on the screen, visually on the screen. Python also provides some really powerful string handling functions. This is going to make data processing very easy. Maybe we've got a spreadsheet that we want to analyze. Well, Python can read in the spreadsheet and split it up into parts and see, okay, this column looks like this and this column looks like this, and it can do that very easily. It also has some wonderfully useful data structures, and we're going to talk about 3 of them today. We're going to talk about lists. Excuse me. We're going to talk about lists and dictionaries and tuples, and Python allows us to use these to do some pretty complex tasks very simply, which is why Python is widely used as a back-end language. So here's about the simplest Python program I could create. It has 2 lines. The first line says shebang user bin Python. Shebang is computer science speak for hash bang. It's a quick way to say hash bang. The hash, or the number sign, is the first character, and the bang or exclamation point is the second character. And it's followed by a path that tells it what program to run to interpret the file. So this is a way of saying this is a Python file, and you should run this version of Python to understand it. So hash bang / user / bin / Python will be at the top of every single Python script you create for this class. And then that is followed by a print statement. Now, in Python version 2, print was a built-in keyword. It was part of a Python language. We're going to use Python version 3 in this class. And in Python 3, print has been replaced by a print function. So when we call functions, we're going to use parentheses. The parentheses are required. So if you go online and you look at examples and you see print without parentheses, you'll know that they're using Python version 2, and you should find a different resource to understand how Python works. So here I'm saying print, and then I have my parentheses for my function, and inside I have the string hello world. Notice that I put hello world inside double quotes. That tells Python that hello world is a string literal. In other words, I want it to print literally the words hello world. I don't want it to think that hello world is some sort of variable and try to go look up what hello world means. I want it to actually print hello world. And that's what the double quotes do. Now, Python actually allows you to use 3 different kinds of quote marks for strings. You can use single quotes, like I've done here, print single quote hello, single quote. Or you can use double quotes, print double quote goodbye, double quote. Or there's a third option. I can use what are called triple double quotes, or triple doubles. And if I use triple doubles, the advantage is that I can actually wrap to multiple lines. So here I've printed anything that can go wrong will, at the worst possible moment. And then on the next line, I've printed Finagle's Law, which, by the way, is the name of this famous statement. Murphy's Law, of course, says that anything that can go wrong will. Finagle's Law adds at the worst possible moment. But notice the important thing here, I have triple double quotes at the beginning, I have triple double quotes at the end. That's just 3 double quote marks in a row. So I can use this to generate a web page. So notice at the top of my file, I have my magic, my hashbang, my shebang user bin Python. Then I print content type : text/HTML. The reason that I have to do this is that my script has to generate not just a web page, but an HTTP response message. So I have to put in not only the body, the content, the web page, but also the headers that go at the top of an HTTP response. So the only one that I absolutely have to have is the content type header. So that's the one I'm providing here. I'm telling it that this is an HTML file that I'm producing. Remember, because I'm generating this from a script, it doesn't have a file name. And so it can't look at the extension and say, oh yeah, that's HTML. The only way it has to know that the text that I'm generating is HTML is to look at the content type header. So I'm going to print content type : text/HTML. And then I'm going to print a blank line. Notice that my triple double quotes don't have anything after them for one line. That's so I can print a blank line that will separate the headers from the body. And then the body of my HTTP response is a valid HTML web page. I've got my doctype HTML tag. I've got my HTML and my /HTML. Notice my HTML tag has a lang_gets_en attribute to set the language to English. I've got a valid head and body section. And in my head section, I have the title, which I've set to example page. In the body, I have an H2 element that just says example in big block letters. And then I have a paragraph that says this is an example paragraph. So if I run this in the Python interpreter by typing Python in the name of my script, it prints this. Notice it prints the content type header, it prints a blank line, and then it prints my little web document. Now, I don't want the user to actually see this. I don't want them to see bracket HTML lang=en, right? I want the web browser to interpret this as an HTML page and display it on the page. And if I access this file through a web server, that's exactly what will happen. So if I pull this up on marmerstein.org, which is my web server, it looks like this. Example, this is an HTML page. Example is, of course, my H2 element, and this is an example page as my paragraph. So a couple hints. For this to work, you have to access the page through a web server, because the web server has to run the script. If I just go to the file, my script file, directly, it's going to pull up the source code for my script and not actually run it and give me the HTML it produces. Secondly, in order to be able to do this, you have to set permissions properly so that the web server has permission to execute the script and run it. So you have to add execute permission for your script. On Gandalf, you can do that by typing chmod plus x and then the file name. Chmod, by the way, stands for change mode. In Linux, permissions are also called the file mode. The mode of the file is what set of permissions is set. So here we're adding execute permission to hello.cgi. And of course, you have to have the magic at the top, the shebang user bin Python. If you don't have those 3 things, not going to work. So let's talk a little bit about the basics of Python. And when we're comfortable talking about how Python works, then we'll talk more about how to use it to generate web pages. So like all programming languages, Python stores its data in variables. And like JavaScript, which we've studied, Python is a weakly typed language. That means that you don't have to declare your variables before you use them. I can just create a variable on the fly like this. I can say num gets 34. That will make a variable named num, and it will put the integer 34 into it. I can also say name gets Bob, and put double quotes around Bob to make it a string literal. And it will create a new variable, name, and make it of type string. Similarly, I can say value gets -24.5, and it'll put a floating point number into value. One of the neat things about Python is that it supports large integers, large numbers. I can put a number that is really super long into Python, and I can do math on it, and it will work. In most programming languages like C and Java and even C++, if you try to do this, integer overflow will occur. It's trying to actually store it in a register on the CPU, and that register has a fixed number of bits. Maybe it's 32 bits, maybe it's 64 bits, but there's some maximum size that a number can be. And if you try to go beyond that, either some kind of error will occur, an exception will be thrown, or maybe it'll just wrap around and become negative, and you won't know what's happened. Weird stuff can happen. By the way, errors like that often cause problems for the space shuttle. The French launched an Ariane 5 rocket that blew up because they weren't taking integer overflow into account. So very important that we think about these kinds of things. Python makes it easy. Python just lets us have really big numbers, and we don't have to worry about overflow. By the way, if the numbers get really big, it does slow down your program. That's the cost. But we're probably not going to run into that in this class. In addition to having simple variables, Python provides 3 very useful built-in data structures. And those data structures are lists, tuples, and dictionaries. A list is just an ordered sequence of items. It's a lot like an array in JavaScript or in Java. And we can create a list by using square bracket notation. So for example, we can create a list called nums by saying nums gets, and in square brackets, 1, 2, 3, 4, 5. Similarly, Python provides tuples. Tuples are also ordered lists, but they are immutable lists. What does that mean? Well, I can grow and shrink lists, but I can't grow and shrink tuples. So I could add a 6 to the nums list. I could have 1, 2, 3, 4, 5, and then I could add 6. But I can't say 4, 5, 3 and grow my tuple to have an extra element. It's always going to have exactly 2 coordinates. Dictionaries are sometimes called associative arrays, and they are a way to provide a mapping. So they're very similar to C++ map. Java also has associative arrays. Most programming languages provide associative arrays in some form, either directly in the language or as a library. But dictionaries in Python are very powerful and very easy to use. And basically, they say, OK, map this item to some other item. So for example, I can have a scores dictionary that says Bob's score is 20, and Ursula's score is 70, and John's score is 10. And I just put them in curly braces and separate them with commas. So you can tell if something's a list in Python if it uses square brackets. You can tell if something is a tuple because it will use parentheses. And you can tell if something is a dictionary because it will use curly braces. So to use lists and tuples, we use square bracket notation again. So here I've created a list that contains the strings Robert, Susan, and John. I've also created a tuple, nums, that has the values 1, 5, 7, 9, 15, that's supposed to be a 22, and 80. And if I print out names square bracket 1, that will print out the second item in the list. So it'll print out Susan. Now, why does it print out the second item when I asked it for item 1? Well, in computer science, we count from 0. So the first item is in position 0. The second item is in position 1. So Susan is in position 1. So Robert, position 0, Susan, position 1, John, position 2. I know that's a little confusing, but you'll get used to it as you work with it. Similarly, I can print out nums sub 2, and it will print out the 7. The 1 is in position 0. The 5 is in position 1. So if I print out nums in position 2, nums sub 2, I'll get the 7. And again, I just put square brackets around the index. Another thing that you can do with lists is add them together. So I can create 2 lists. And here I've created list 1 and list 2. List 1 has the strings Bob and Mary. List 2 has the strings Mary and Sean. I can create a new list, list 3, by adding list 1 and list 2. If I do that and print out list 3, I'm going to get Bob, Mary, Mary, Sean. It took all the things in list 2 and added them to the end of list 1 to create a new list, list 3. Notice that Mary is there twice. She was there at the end of list 1, and she was there again at the beginning of list 2. So when I add lists, it's not like set union. It doesn't throw away duplicates. I'm actually adding information to the end. So it's going to keep Bob and Mary, and then add Mary and Sean, and I'll have all 4. This is really useful, actually. It means that I can also use addition to grow a list. I can add it to itself. And Python provides a shortcut notation for this. I can say list 1 plus equals to add to the end of the list. Notice I have to put square brackets around the string Tom because I can't add a string to a list. If I do, it won't work the way that you think it does. It'll take each letter of the string and add that to the list. But if I put the string Tom into square brackets, now Tom is a list, and I can add 2 lists together. So it'll actually create a list that says Bob, Mary, Tom. If I want to access a dictionary, I have to access it using a key. And so dictionaries consist of key-value pairs. So here I'm creating a dictionary named passwords. My keys are Robert, Emily, and Jonas. And they are separated from their values with a colon. The values are Gideon 123, Longwood Cheer, with 3s for the E's, and Botistic 78. If I want to access Emily's password, I could print password sub Emily. Here I've shown you how to access Robert's password. So print, and in parentheses, because print is a function, passwords, and in square brackets, I put the string Robert, and it will print Gideon 123 because that is Robert's password. Another way to access the contents of a list or a tuple is to loop through the different elements. So if I create a list, and here's my names list again, Robert, Susan, John, I can say for name, in names, print name. And names, of course, is my list. The in operator takes each thing in that list and gives it a new variable name. And in this case, that variable name is name. That was a lot of names in one sentence. I apologize for that. But name now is a variable that I can access, and I'm going to loop through the list. So we're going to run through this loop 3 times. The first time, name will be Robert. The second time, name will be Susan. And the last time, name will be John. And so it will print Robert, Susan, John. Another way to do loops is to use a range. There's a range function in Python that takes a starting point and a size. And it will repeat that number of times, giving a variable. Actually, let me say this a different way. If I say for x in range 0, 5, x will be treated like my index. X is going to start at 0, then it will become 1, then it will become 2, then it will become 3, and then it will become 4. It doesn't actually become 5 because 5 is not the ending point. 5 is the number of times to loop. So it's going to loop 5 times. The first time it will be 0, the last time it will be 4. If you count 0, 1, 2, 3, 4, that's 5 things. So here in my loop, I print out 0, 1, 2, 3, 4. I can also loop using dictionaries, but I can't actually loop through the dictionary itself. I have to loop through the keys of the dictionary. So here I can create a dictionary called authors, and I've mapped the words the Iliad to Homer, because Homer wrote the Iliad, and 1984 to Orwell. George Orwell, of course, wrote 1984. And then I can loop through my keys by saying for key in authors. That actually should say authors.keys, I believe. And it'll set key to be the Iliad first and then 1984. So I can print out title plus the key, and it'll print title, the Iliad. And then I print out author colon and author's sub key is how I access a dictionary. And so it'll print out Homer. So it'll print title, the Iliad, author, Homer. Then it will loop, and it will print out title, 1984, and author, Orwell. For loops are one way to repeat in Python. Python for loops are always used with some sort of list, or for instance, the keys of a dictionary or a list in Python, but some iterable object. Python also, however, supports while loops. And these you can loop using any generic condition. So here I've created a variable named count. It's just a number, and I've set it initially to 0. Then I say while count is less than 20. And notice the syntax here. I just put a colon at the end, and then I tab over the contents of the loop. If you go back to the previous slide, you'll notice that I did the same thing with the for loop. So I tab over, and I'm going to print meh. And then I'm going to set count equal to count plus 1. This will add 1 to the count. So count will be 0, and it will print meh. It'll add 1, so count will become 1. It'll check if count is less than 20. It is. So it'll print meh again. Then it'll add 1 more to count, so count will become 2. And I'll repeat until the count becomes 20, and then the loop will stop. So this will print 20 meh strings to the screen. I want to point out I did count equals count plus 1. I can actually say count plus equals 1, but I can't say plus plus count like you might be used to in other programming languages. Python doesn't support plus plus and minus minus, at least not yet. One of the beauties of Python is that they have a really straightforward and well-defined process for suggesting improvements to the language. So you can create a Python enhancement proposal and submit it to the developers, and Guido van Rossum and the other Python developers will talk about it on the mailing list and decide if your proposal has merit. And if it does, it gets incorporated into the language at some point, which is pretty neat. Most languages have some sort of standardization process, but it usually isn't as straightforward as the one that Python follows, in my opinion. We can also make decisions. We can repeat things over and over with loops, but we can also make decisions about things. We can say, do this code if something's true, but do something else if it's not. And as with other programming languages, we do that with an if statement. So here I've said, if the name is Robert, print welcome master. Otherwise, if the name is Susan, print your carriage awaits. And otherwise print, who are you? So this is my if statement. Notice a couple things about this. First of all, I don't have to put parentheses around my conditions. I know in Java and C++ and a lot of other languages, you have to put the condition in parentheses. Not in Python. In Python, you can put in parentheses, but you don't have to. You can just say if the name is equal to Robert. Also, in Python, if I want to have an else if clause, the keyword that I use is elif, E-L-I-F. I don't say elzif with an S. I don't say else if, two words. I just say elif, E-L-I-F. And I can have several elif conditions in an if statement. Python actually supports some pretty complex conditions. So here I have name equals Robert and in parentheses I've grouped together some more conditions. The age is greater than 60, or it is not true that discount is equal to senior. So you may be familiar with using ampersand in Java or C++ to represent and. In Python, you just use the word and all lowercase, and that'll join two conditions, do what we call conjunction. To do disjunction, or, you don't use two vertical bars. You just use the keyword or, O-R. And the opposite of something you can get with the not keyword, N-O-T. Python also provides functions. A function, of course, is a way to group some code together so that it can be reused. And here I have an example of a function that's provided for us by Python, the length function. So suppose I have a variable x and I set it equal to the string literal, so I have double quotes. This is a long example string, period. I can call the len function on x to get its length. So I can set a new variable length equal to len, and in parentheses, I can put x. And then I can print the length is, and the length, and it will print the length is 30. So you can actually create your own functions in Python. That's very easy. You just use the def keyword, D-E-F. So I'm going to define a function named sum that adds two numbers. So here I say def sum, in parentheses, a comma b. And then I close my parentheses and I have a colon. And I just tab things over to show what code goes in the function. So I'm going to tab it over and I'm going to return a plus b. So if I were to ask Python for the sum of 2 comma 3, it would return 5. So pretty easy to create functions in Python. You can also import modules of code. Modules are sometimes called libraries in other programming languages. We call them modules in Python. And we use the import command to pull them in. One of the modules that you can import is the CGI module, which of course stands for Common Gateway Interface. And this will give us access to the data in an HTML form. So to do that, I just say import CGI at the top of my file. And now I can use the CGI functions. So if I want to access the elements of a form, I use the CGI module. And I use a class inside that module called the field storage class. It's pretty easy to use. I import CGI. And then I'm going to create a variable to store the HTML form object. So I'm going to say form gets CGI.fieldStorage, and then parentheses, because field storage is a constructor function. If form has key of name, so I'm checking if the form has a field that had name attribute set to name. Then I'm going to set my Python variable name to be str, and in parentheses, form square bracket name.value. What's going on here? The str function converts something to a string. I actually probably don't need to do that because everything that comes back from a form is usually a string by default. But if I needed to convert it to a number, I might say int here to convert it to an integer. So I thought it would be good to show you how to convert things to strings with str. Inside my parentheses for str, I have form, which is the name of my field storage object. Right? That represents my HTML form. And in square brackets, I have the key name in double quotes. So I'm going to access the name field of the form. And then .value is how I retrieve the value that was assigned to that form element. So now I can print out my response message. My response message has to be an HTTP response message. So it has to have headers and a body. So I'm going to print out my content type header, which it's going to be text/HTML. Then I print a blank line, so I just print. And after my blank line, I'm going to print out a valid HTML document. So here's my doc type tag I'm going to print. Then I'm going to print my HTML tags, my head tag, and my title tags. And then I'm going to print my body. And in my body, I'm going to say your name is. Notice I use double quotes to end the string literal. Then I say plus name plus. And this will actually embed the name that we fetched from the form. And then plus, and in double quotes again, I have the slash body and slash HTML tags. So in summary, Python is an interpreted programming language that we can use to process web forms. It provides all the standard features of a programming language: variables, loops, if statements, and functions. It also has these wonderful list, tuple, and dictionary data structures. If you want to be able to run your Python scripts, you have to make them executable. You do that with chmod plus x and then the file name. You also have to make sure that they start with the magic string, shebang /user/bin/python. I hope that you'll begin playing around with this, that you'll read a little bit about Python. It's a great language. There's a lot of features to Python, far more than I can possibly talk about in this class. But I hope you have fun exploring.